Okay, Waka. Today we're looking at Wednesday, November 28th, solve systems of linear and quadratic equations on page 34. If you would, update your table of contents. All right, now your table of contents are updated. Let's take a look at our notes. All right, solve systems of linear and quadratic equations on page 34. Substitution steps. Step 1, solve one of the equations for either x or y. Step 2, substitute the equation from step 1 into the second equation. Step 3, solve the second equation. Step 4, use the found variables in step 3 to find the other variables. All right. Now, let's look at linear graphing. Now, standard form is ax plus by equals c. The slope, which we know as m, is equal to negative a divided by b. The x-intercept is x equals c divided by a, and the y-intercept is c divided by b. Now in slope-intercept form, y equals mx plus b, m is the slope and b is the y-intercept. And x equals a positive number is a vertical line, and y equals a number is a horizontal line. All right, quadratic graphing. Understand we graph by direction and that there's symmetric points. So notice the negative 1, 1, 1, 1, negative 2, 2, 4, 4, they're symmetric, okay? And they're separated in the middle by the vertex. Now there's types of solutions. One solution is when they intersect once, two solutions when they intersect twice, and no solution when they don't intersect at all. If you would, update your notes. All right, now your notes are updated. Let's move on to the next part. Now, before we move into the lesson, we're just going to do some reviewing of graphing. Okay, so we're going to graph each line. Okay, so to graph A, and let's do this in color. So I'm going to do A is yellow. So remember, the number in front of x is slope, and slope is always fraction, so we're going to divide by 1. Now, that means your m is negative 3 divided by 1, and your b value is 1. And b is your y-intercept, so we start there. So we start at 1, and then slope tells us we go down 3 to the right 1. So down 1, 2, 3 to the right 1, down 1, 2, 3 to the right 1, down 1, 2, 3 to the right 1. And remember, negative 3 divided by 1 can also be written as 3 divided by negative 1. So we could actually go up 3, left 1. So up 1, 2, 3 to the left 1, up 1, 2, 3 to the left 1, up 1, 2, 3 to the left 1. Again, we're going to do A in yellow. Okay. Now let's do B in green. Okay, so y equals 4 is from the notes, is a horizontal line at 4. So 1, 2, 3, 4. So we have a horizontal line at 4. Okay. And then C we'll do in blue. Now, we want to label A, B, and C. And so our x-intercept is C divided by A, which in this case is negative 6 divided by 2, which equals negative 3. So our x-intercept is negative 3, 0. So negative 1, 2, 3, 0. Okay. Now our y-intercept is C divided by B. So C is negative 6. B is negative 3. Negative divided by negative is a positive 2. So our y-intercept is 0, 2. So 0, 2. We have 2 points. 2 points make a line. All right, so that was a review of how to graph linear lines. Okay, now let's review how to graph quadratic functions or lines. Okay, all right, again, I'm going to graph A in yellow. Now, A is a quadratic parent function, so we can graph just using points. Okay. X, Y. So let's do when x is -2, that means -2 squared is 4. Okay. When x is -1, that's -1 squared, which is 1. When x is 0, 0 squared is 0. X is 1, 1 squared is 1. And when x is 2, 2 squared is 4. So our points are -2, 1, 2, 3, 4, -1, 1, 0, 0, 1, 1, 2, 1, 2, 3, 4. Now, it's important that we graph that first because now we can use transformations or graphing by direction to graph B and C. And B, let's do in green. So we're going to graph by direction. Now we know the directions are the points from the parent function. So -2, 4, -1, 1, HK, 1, 1, 2, 4. Now, we need to move the vertex forward, so that tells us we go right 4, up 5. So right 1, 2, 3, 4, up 1, 2, 3, 4, 5. Double check the count. 1, 2, 3, 4, 1, 2, 3, 4, 5. Now, we have to multiply it by -1. So that's -4, -1, -1, -4. So from the vertex, we go left 2, down 1, 2, 3, 4. Left 1, down 1. Right 1, down 1. Right 2, down 1, 2, 3, 4. All right. Now again, we're going to graph by direction. Now, because I know I'm going to have to divide by 4, I'm only going to use the directions -2, H, K, and +2. So that's -2, -4, 2, 4. Now we need to move the vertex. So we go left 1, down 1, 2, 3, 4, 5, 6. Now we have to divide by 4. So that's -1 and that's +1. So we go left 2, down 1, and right 2. Wait, made a mistake somewhere. Hold on. Oh, that's why. Now, the mistake, I apologize, is a squared number is always positive, so that should have been a +4, so that's +1. And the reason why I knew I made a mistake is I know this makes a U shape. Okay, so when it started to not make a U shape, then I went back and looked at what mistake I made. So we go left 2, up 1, right 2, up 1, and we know it makes a U shape based on that. All right, so that's reviewing graphing quadratics. All right, so finish up review 1, review 2. And almost forgot, this is going to be on page 34. So this will be in your journal on page 34. Okay. Now let's look at the review 3, factor. Now we're doing a lot of review because this is the first assignment coming back from Thanksgiving break. That's why we did the gobble gobble and the ornament assignment to kind of review solving and factoring. And we're going to continue that view a little bit more just to refresh you from the Thanksgiving break. Okay, factoring. Now, the first thing you do is you see if there's something you can factor from both of those numbers. Doesn't look like there's can. I see the cubed. So now we know we use the sum and difference of cubes. So we know we need to come back to our notes. And so we know that's A plus B times, and actually pull my notes myself just so I don't make the mistake. Seconds, let's get those notes. So here it is. So we know we're doing the sum of cubes, so there's our form right there. Okay, so A plus B times A squared minus AB plus B squared. All right, so we need to figure out what A and B are first. So A, well, 2 cubed gives us 8, so that's 2x. And then 5 cubed gives us 125. Okay, so then, real simple, we plug those in, so it's 2x plus 5 times 2x squared minus 2x times 5 plus 5 squared. So then that's just 2x plus 5 times 4x squared minus 10x plus 25. All right, now let's look at the next one, review 4 factor. All right, 3 terms, we see the squared, so we do reverse box method. First term, last term. So we know 2x and 1x make 2x squared. Now we need to find all the combinations of -3. So 1 times -3 is -3. 2 doesn't work. 3 times -1 equals -3. Now our middle term is 5x. Because of the 2 and 1, we have to actually multiply the first number by 1 or 2 and the second number by 1 to find 5. So that's 2 times 1 plus 1 times -3, which is -1. And then we do 2 times 3 plus 1 times -1, which is 5. Well, that's our middle term. We know the 3 goes with the 2, and the -1 goes with 1. So that's plus 3 minus 1. So 2x times 3 is 6x. -1 times 1 is -1x. 6x minus 1x is 5x. This works. So our factors are 2x minus 1 times 1x plus 3. All right, review number 5. Okay. I see 4 terms, so I think automatically factor by grouping. All right, so now it looks like we can factor out 5x squared from both terms, which leaves 1x minus 1. And it looks like we can factor out a -45 from both terms, which leaves 1x minus 1. These are the same, so we group them together. So 5x squared minus 45 times 1x minus 1. We can factor a 5 out from each of these terms, so that's 5, 1x squared minus 9 times 1x minus 1. We're almost done, but I noticed that this is a difference of squares. So this can be factored 5 times 1x minus 3 and 1x plus 3. And then we can't forget about the 1x minus 1. All right, review 6. Factor. 3 terms, reverse box method. First term is 1x squared, last term is negative 24. This one's going to be easier than review 4 because this had a 2 and 1. When it just has 1 and 1, the factoring is much easier. Okay, middle term is 5x. So again, we find all the combinations to make negative 24. So 1 times negative 24 is negative 24. 2 times negative 12 is negative 24. 3 times negative 8 is negative 24. 4 times negative 6, so yeah, is negative 24. 5 doesn't work. 6 times negative 4 is negative 24. Now we look at which combination makes positive 5x. It looks like 3 negative 8, but that 3 minus 8 makes negative 5. So it makes me wonder if we come down here and did 8 times negative 3. So then 8 minus 3 is positive 5. So then it's plus 8 minus 3. So that's 8x, negative 3x, positive 5x. So our factors are 1x plus 8 times 1x minus 3. All right, so that's your review, some of the key components that we learned from last semester. Now let's return back to solve systems of linear and quadratic equations. All right, example 1. Solve the system of equations using substitution. Okay, so when we substitute, we make a table. So we have y equals x plus 2 and y equals x squared. Now here, since they're both equal to y, we can set them equal to each other. So I can say that x squared equals 1x plus 2. Now, because they're squared, in order to solve this, we need to move everything to the left side. So we're going to subtract 1x and subtract 2 from both sides so that we get 1x squared minus 1x minus 2 equal to 0. Okay. Now, it looks like to solve this, the best way would be to do is find the factors and set them equal to 0. So we need to use the reverse box method. First term, last term. Now we know this is 1x and 1x. And in order, we need a middle term of negative 1x. So we need to find all the factors of negative 2. So negative 1 times 2 is negative 2. And then negative 2 times 1 is negative 2. Well, which combination would give us negative 1? The negative 2 and 1. So minus 2 plus 1. Make sure it works. Negative 2x, 1x. That gives us negative 1x. So we set each of those equal to 0. So x minus 2 equal to 0 and x plus 1 equal to 0. So x equals 2 and x equals negative 1. Now, we need to plug those into y. So y equals 2 squared, which is 4. So one of our solutions is 2 comma 4. Now we need to plug negative 1 in. So y equals negative 1 squared, which is 1. So our other solution is negative 1 comma 1. Now you'll notice that example 1 and example 2, they're the same system because I wanted to see that you could solve it using substitution, but you can also solve it using graphing. Okay. Now to graph the first equation, we know this is 1, but we also know it's divided by 1. That's our y-intercept. There's our slope. So we start at 2, so 1, 2. And our slope is 1 over 1. So we go up 1 to the right 1, 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 up 1 to the right 1. Now, 1 divided by 1 is equivalent to negative 1 divided by negative 1. So we can actually go down 1, left 1, down 1, left 1, down 1, left 1, down 1, left 1, down 1, left 1. Okay? And the reason why you want to put every point, because you're looking for the intersection, so it's going to be easier if you have every point. Now, this is the parent function, so we know the points for the parent function. Y are, when x is negative 2 squared is 4. When x is negative 1 squared is 1. When x is 0 squared is 0. So we go left 2, up 1, 2, 3, 4. Left 1, up 1. There verifies one of our solutions. 0, 0. Now we know it's symmetric, so we know that negative 1, 1 is symmetric to 1, 1, and negative 2, 4 is symmetric to 2, 1, 2, 3, 4. There's our other solution. So there's our intersection, and there's our intersection, which verifies these two solutions. So our solutions are 2, 4, and negative 1, 1. And I probably should have done these in different colors to see the difference. So let's do the first one in yellow and the second one in green. All right, let's take a look at example 3. All right, solve by substitution. Now you can see automatically that they're both equal to y, so we can set them equal to each other. So we can start off by saying x squared minus 2 equals negative 2. Okay? So then we solve for x. So we add 2 to both sides. So x squared equals 0. We're going to take the square root both sides. Now, don't forget square root's plus or minus, but it doesn't matter because it's 0, so x equals 0. Now, we need to remember to plug this back in and solve for y. So y equals 0 squared minus 2, so y equals negative 2. So our point of intersection is 0, negative 2. Okay, so now, again, notice example 3 and 4, okay, are the same. So I wanted to see it by substitution and by graphing, okay? Now here, y is just a horizontal line at negative 2. And here we graph by direction. Now we first move the vertex down 2. There's our point. We already found it, 0, negative 2. So now we just graph by direction, negative 2, 4, negative 1, 1, HK, 1, 1, 2, 4. So left 2, up 1, 2, 3, 4. Left 1, up 1. Right 1, up 1. Right 2, up 4. All right, and almost forgot. Don't forget this page is on page 34 in your journal. All right, example 5. Solve the system equations using substitution if you can. So here we see that they're equal to y, so we set them equal to each other. So we have negative 6 divided by 5 x plus 9 equals negative 1 parentheses x minus 4 squared plus 2. So we need to distribute the negative 1 first. Actually, let's get rid of the fraction first. We're going to multiply by 5. So then that's 5 times negative 6 is negative 6, or negative 30 divided by 5 is negative 6. So negative 6x plus 9 times 5 is 45, I believe. All right. I've checked with my, I don't know if you ever calculate with your fingers, but I checked with my calculator fingers, and that's 45. So then that's negative 1, and that's x minus 4 times x minus 4 plus 2. We need to FOIL this, so then we're not doing anything with this. Negative 6x plus 45 equals negative 1, x squared minus 4x minus 4x plus 16 plus 2. Now we need to multiply by negative 1, so negative 6x plus 45 equals negative 1x squared plus 4x plus 4x minus 16 plus 2. Let's go and move everything over. So we're going to add 6x to both sides and subtract 45 from both sides. So then we get 0 equals negative 1x squared plus 16x and then minus, see, let me grab a calculator so I make a mistake on that. Is negative 59. Now you first want to factor out a negative 1 first. So 0 is negative 1, 1x squared minus 16x plus 59. Now we want to see if any combinations make 59 will actually also make negative 16. So we want to go in order, find all the combinations. So negative 1 times 59 equals negative 59. Negative one of the tricks I use to find factors quickly is I just take negative 59 divided by x, and then I press Control T, and then so you can see 1 negative 59 works, 2 doesn't work, 3 doesn't work, 4 doesn't work, 5 doesn't work, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Where 22 still not working. All right, so the only two combinations that work are negative 59 times 1. Neither of these combinations gives you negative 16, so we know it's not factorable. Okay. So let's see. We're applying the same problems. Okay. Let's see what not factorable looks like when we solve the system by graphing. Okay. Now to graph the first line, we start at 9, so 0, 9. And we go down 6 to the right 5. So down 1, 2, 3, 4, 5, 6 to the right 1, 2, 3, 4, 5. Down 1, 2, 3, 4, 5, 6 to the right 1, 2, 3, 4, 5. All right, and we're going to do that in yellow. Now let's graph this, and we're going to graph by direction. We first graph, and actually, one thing that I just noticed is I know I'm going to have to multiply by -1, so let's make this line a little bit further to the left so we have space for that multiplying by -1. So we know our directions are -2, 4, -1, 1, H, K, 1, 1, 2, 4. We move the vertex, it looks like right 1, 2, 3, 4, up 1, 2. Okay, now we multiply these by -1. So that's -4, -1, -1, -4. So we go to the right 2. I'm sorry, this is left 2, down 1, 2, 3, 4. Left 1, down 1. Right 1, down 1. Right 2, down 1, 2, 3, 4. You see here that they don't intersect. If they don't intersect, there's no solution. Okay, so if it's not factorable, it means that they're not going to intersect, and there'll be no solution in this case. In other cases, when it says not factorable, it could be a solution, but in this case, it meant no solution. All right, so with that finishes up the longest video of your entire life. So with that, start working on the lesson and have a wonderful Wildcat day. Or I said lesson, I should really mean assignment. But as always, you should always have a wonderful Wildcat day.